Hi all, I am Kripa Maramsani. Today I am going to talk to you about remote sensing. So let's understand the term remote sensing. Remote, that means something which is not in contact with the target, and sensing, the second word sensing means getting information, getting data, getting any input. The input could be something like temperature, pressure, photographs, etc. These are the contents of my topic. Introduction, what is remote sensing, history of remote sensing, applications of remote sensing, components, advantages of remote sensing, disadvantages of remote sensing, references, conclusion. Introduction. Remote sensing is the art and science of recording, measuring, and analyzing information about a phenomenon from a distance. Humans, with the aid of their eyes, noses, and ears, are constantly seeing, smelling, and hearing things from a distance as they move through an environment. Thus, humans are naturally designed to be remote sensors. In order to study large areas of the Earth's surface, geographers use devices known as remote sensors. Next, what is remote sensing? Remote sensing is defined as the technique of obtaining information about objects through the analysis of data collected by special instruments that are not in physical contact with the objects of investigation. That is, collection of information about an object without coming into physical contact. The electromagnetic radiation is normally used as an information carrier in a remote sensing. The output of a remote sensing system is usually an image representing the scene being observed. Next, history of remote sensing. Aerial photography is the original form of remote sensing, started in 1909. Photogrammetric engineering, the official monthly publication of the American Society of Photogrammetry, was first published in 1934. Color infrared photography began 1931, then was widely used in agriculture and forestry. Development of radar 1930 to 1940. During WWII, non-visible spectrum were used as tool in remote sensing. Next types. There are mainly two types of remote sensing. They are passive remote sensing and active remote sensing. Passive remote sensing is classified into three: photography, radiometry, radiometers, and infrared. Active remote sensing is classified into two: radar and lidar. Next is the application of remote sensing. Following is the application. First one, meteorology. Meteorology means profiling of atmospheric temperature and water vapor, measuring wind velocity. This is meteorology. Next, oceanography. Oceanography means measurement of sea surface temperature and mapping ocean currents. Next, glaciology. It means mapping motion of sea ice and ice sheets, determining the navigability of the sea. Next, geology. Identification of rock types and location of geological faults and anomalies. Agriculture. Monitoring the extent and type of vegetation and mapping soil types. Next, hydrology. Accessing water resources and forecasting water runoff from snow. Last one is disaster control. Warning of sand and dust storms, flooding, monitoring of pollution. Next, why is remote sensing important? Remote sensing makes it is possible to collect data on dangerous and inaccessible areas. Remote sensing provides real-time updates and does not require active human assistance. Remote sensing can direct things that are normally present in the visible spectrum, for example temperature, or by directing landforms underneath the surface of the ground of ocean. Remote sensing can scan large areas of land by satellite much more quickly than a ground survey ever could. Next, components. These are the components of remote sensing. First one is energy source or illumination. That means the first requirement for remote sensing is to have an energy source which illuminates or provides electromagnetic energy to the target of interest. Next one is radiation and the atmosphere. As the energy travels from its source to the target, it will come in contact with and interact with the atmosphere it passes through. The interaction may take place a second of time as the energy travels from the target to the sensor. Next one is interaction with the target. Once the energy makes its way to the target through the atmosphere, it interacts with the target depending on the properties of both the target and the radiation. Recording of energy by the sensor. After the energy has been scattered by or eliminated from the target, we require a sensor to collect and record the electromagnetic radiation. Next, advantages of remote sensing. Provides data of large areas. Next, provides data of very remote and inaccessible regions. Relatively inexpensive when compared to employing a team of surveyors. Easy and rapid collection of data. Rapid production of maps for interpretation. Next, disadvantages of remote sensing. The interpretation of imagery requires a certain skill level, needs cross verification with ground survey data. Data from multiple sources may create confusion. Objects can be misclassified or confused. Distortions may occur in an image due to the relative motion of sensor and source. We are going to the conclusion of this presentation. At last, remote sensing proves itself as a boom in an economic growth all over the world. Various applications in the field of agriculture, forestry, satellite, radars, geology, search and rescue operation help in the development of economies around the world. Hence, it promises a great future. Thank you.